This video is made to show the unconventional and informal way of this channel. I hope this channel will be talking about topics and subjects, because when I was in MYP, I had a very big difficulty like learning and revising in in a serious manner. So this is a unconventional and serious way to talk about every topic of the MYP science, at least MYP science and maths, because that's what I am good at. This video is planned to show others how this tone, how this informal way of talking is is exists, and I will use this video to try to invite other people to join me. But if no one ends up joining me, I will make full discussion, full topics regarding all the MYP sciences and maths topics. I even have the textbooks, which I still have. Like, these are textbooks that I bought myself. Well, my mother bought for me when I was MYP. So I have the textbooks, I have the whatever to do it myself, but I will use this video to invite others. Hello, I'm Tom. I'll be your, not teacher, your your revision tutor maybe? Your revision tutor today at Chaotic Learning, and I will explain some high school topics in ways that you probably could understand, but this judgment of whether you could understand is highly based on my stereotype. So let's get on with what was that? First, what a model is. A model is basically a oversimplification of something, so to make it easier to calculate and whatnot. So for the boys, I assume you all play Fortnite because you are younger than me, and that's my stereotype for people younger than me. So Fortnite. Fortnite, there's a bunch of like towns and stuff with resources and whatnot. I honestly don't remember where they are. I haven't played in like 5 years. Oh, 5 years. So maybe not 5 years, like 3 years. I haven't played since like chapter 1, season 7. So if you know like the Fortnite history, go for it. Anyways, there's a bunch of resources. There's a bunch of people who are picking up the resources, and who wants to fight each other basically. And that is very difficult to like actually calculate what will happen. So to simulate what would happen. So there is a model of a player, and when the player has enough resources, they start going in for the kill, and whether he kills others or he gets killed, it will fully depend on who has more resources. Like, that is a oversimplification. There's no like skill, no training, no who has a shotgun, who has a sniper, no distance. Just whoever has more resources is more likely to win. That's what I was trying to say. Good job. What was that? What was... Never mind. Dating sims. That is the complete opposite of Fortnite, I think. Don't, don't quote me on this. Okay, dating sims. Dating sims is a model. Wait, no, for girls, it's not a model. For girls, it's like far more difficult than actual dating. Most guys at this age, even at my age, as long as the girl shows like any interest back, he will probably like her. So dating sim is not a model. It's a model of the ideal stuff, the ideal of how an ideal dating should be. It's a model of that. So figure model. And I think that's enough of an example. Okay, models, specifics, atomic structures, particles, edit, future editor, which will also be me. Cut that. Clear cut that you most likely have noticed. I don't know where the cut started from, because there was just a thingy that just happened, so I'm not sure from where I'm cut it. But we're back. Okay. Atomic structure. There's a big thing there, and there's a bunch of small things around. In this case, I'm only gonna actually small thing. This so you can better see it, and this so you can understand like what I'm trying to say. Okay, that looks like a sunny side up egg. Don't look at it that way. It will be sad. I will be sad because my drawing skills are horrible. Okay, this. Let me just. Yay. This big thing in the center is the nucleus. The nucleus has some more stuff in it. The nucleus of most atoms or elements are formed from protons and let's say neutrons. But in this case, it's just helium, which is one proton and one electron. The small things are electrons. They are way smaller in comparison to protons than this shows here. Electrons are like, wait, electrons are closer to this compared to like this whole piece of paper multiplied by like 7 or 8, and that's just like a tad bit closer. Anyways, continue. Where was I? This is electrons, this is protons, this is neutrons. Electrons are negative. Electrons have negative charge. Protons are positive. Protons have positive charge. Neutrons are made from when a proton and a electron combine. At least that's how I understand it from chemistry, from like a bunch later chemistry, but that's not. My guess is that that's not exactly the correct either, but just understand that neutrons are positive and negative, which cancel out, so it doesn't have a charge. Protons are positive and electrons are negative. That's generally charges, particles, and whatnot already. Atomic structure, it's one nucleus, and then it's the electron, and the nucleus has protons and neutrons. I think that's a good enough explanation. Next, interaction, gravity and gravitational fields. Okay, nothing about thermodynamic, but whatever yet, so not gonna worry about that yet. Gravity is also quite simple. All these dots want to be closer to other dots, and none of the dots want to move. But they decide on a system like whoever is closest to more dots move less. So this dot, wait, so this dot, because it's far from the four, it needs to move that way. This because it's far from the other four, it needs to move that way. Or I wait, let me do the calculation. That's two. That's weak. Okay. This will move this way. This will move this way, but it will like all figure itself out. Like everything changes. Changes like what's it called? Everything changes as everything happens, and that's calculus and physics. But eventually, what results will be the middle dot, which was this one, hasn't moved much, and every other dot, like every other particle, moves closer to it. Okay, particle. That's like with particles, generally the same size. Okay, it's this dot and this dot. No, that's too big. Like this dot. Okay. This dot, the size of this dot is very big. The size of this dot is around half of that dot by side. Not the radius is half the size, like the area of the dot. So, yeah, the area of the dot is around half of that dot. Yeah, around half of that dot. So when this moves 1 unit of space, this moves 2 units of space. This will move more to get closer to this dot. The smaller dot will move more to get closer to the big dot. Then the big dot moves to get closer to the smaller dot, and these two dots combined moves less than these four dots combined to get you when they are trying to get to each other, because even though these small dots have more dots, the big dots have more mass, which in this case means bigger. Okay, mass longer static electricity is okay. Static electricity, I think, will be better like later after we've learned some other stuff. States of. Okay, let's talk about thermal physics, which is like a bunch of units afterwards. But it's like something that I struggled with for a bit, so I'm gonna talk about that because I actually I don't have reason to. Eh, I'm gonna talk about the like thermal physics. Eh, okay. Uh. Uh. I'm gonna talk about thermal convection. About like convection because that's what I like could simply understand, but it wasn't explained in a way that I would immediately understand. So I'm gonna explain it in a more understandable way. So there are energetic guys and not energetic guys, and you are all standing on a ramp. At the bottom of the ramp, it's very crowded, and at the top of the ramp, it's like far less crowded. And this is like the amount of people along across the ramp. Okay, so now everyone else is like standing still or just generally swinging around without moving much, and you are one of these guys. But now you suddenly have energy. You want to move. You want to get around. So when you try to go that direction, the direction that the tip of the pen is pointing at, there's like a huge crowd there, and you can't shove in. And when you try to go the other direction to go upward, even though there is the ramp that like drains your energy from going upward, when you go upward, there's less resistance. It's less crowded, so you can easily go upwards. You can easily go upwards. And then if you try to go back that when you try to go back when you try to go back down, like it's very crowded. It's very crowded, so you don't want so you can't exactly go back down. And you go so you eventually end up going up again, and then you randomly move until you go up again, and whenever you randomly move to go back down, you get stopped because it's too crowded. And this continues happening until you are out of energy, like because whenever you bump into another particle, you lose some energy. So now you're up here, and you don't have any more energy, and you slowly go back down the slope because you don't have energy, so you're not moving upwards, and the gravity pulls you down. And this happens without a slope. This happens to air, to like any fluid without a slope, but the slope is so that you as a person can understand it better. Now how do I rotate this? uh uh Here. Like this happens. uh no, that's a full square. Okay, this happens. Why is that white? This happens either. This happens when it's like standing tall as well. I'm not gonna draw a box. You get the idea. At least I think you do. Anyways, that's the convection for you. Uh, yeah, I think this is like far too long, and me just talking to myself for this is not exactly the idea either.